Now let us apply the moment area theorems for simply supported beam and cantilever beams. So if I take a simply supported beam here, say AB, and if you draw the tangent at A to the deflected curve or elastic curve at A, the angle made with the tangent to the deflected curve with respect to axis of the beam. This is axis of the beam, we call it as slope at A. Similarly, if you draw the tangent at B, it will come like this. The angle made by the deflected curve at B with respect to axis of the beam, this is axis of the beam, we will be taking it as theta B. Now, let us recall the moment area theorem number 1. What the moment area theorem number 1 says? The area of the M by EI diagram between any two points gives us the change in slope between those two points. Suppose assume that this is the M by EI diagram. If you take the area between this, say A and B points, it gives you change in slope between the points A and B. What is change in slope between the A and B? That is nothing but angle between the tangents drawn at those 2 points. This is the angle drawn, this is the tangent drawn at B, this is the tangent drawn at A. The angle between these 2 tangents is this. That is what we call it as a theta BA. That means angle between these 2 tangents gives you change in slope between these 2 points. Now directly to get this, you have to take the area of the M by A diagram between these 2 points. That is what the moment area theorem number 1 says. Now moment area number 2, if you take, it is regarding tangential deviation. To get the tangential deviation, what is tangential deviation at A? It is a vertical distance at B with respect to tangent drawn from A. Means this is the tangent drawn at A, this is the tangent drawn at B. So if you take this point, this vertical distance between the point B and the tangent from A gives you the tangential deviation with respect to A. Suppose now I want tangential deviation of A, means you have to draw the tangent at B, the vertical distance between the tangent drawn at B on A with respect to A. This vertical distance we call it as a TAB. Here TAB and TBA not necessarily equal. So it depends upon the type of the loading. So here, now how to get the TBA now? What is this second moment area theorem summary? If you want to get the TBA, it is nothing but tangential deviation of B with respect to A. You have to take the moment of the M by EI diagram between these 2 points about B. Means suppose say now this is the M by EI diagram. If you take the area of the M by diagram between these 2 points about B, means you have to multiply the area of the M by diagram between these 2 points with respect to multiply the distance of CG with respect to B. Say let us say x1 bar is the distance of CG with respect to B. Then area of M by DI diagram multiplied by x1 bar gives you TBA. Suppose if you want TAB, now you have to take the area of the moment of the area of M by EI diagram between these 2 points about A. Means because I am finding the tangent deviation at A. Then the area of the M by EI diagram between these 2 points multiplied by the distance of CG of that figure or M by EI diagram from A. Let us say x2 bar is the distance of CG of this figure from A. Then area of M by EI diagram multiplied by x2 bar gives you TAB. Okay. Now let us apply this theorem to this cantilever beam. So what is the difference between cantilever beam and simply supported beam? If you look at simply supported beam here, at that the supports, slope will be there, but deflection will be 0. Always at the points of supports, there will be no deflection because support doesn't allow to deflect. Similarly here, slope at B is there, but deflection at B is 0. But if when you take the cantilever beam, so when you draw the tangent at the fixed end, suppose it is like this. See now the tangent comes, deflected curve or latex curve, it comes like this. Means if you draw the tangent at A, the tangent comes along the axis of the beam. Say here if you draw the tangent at A, it comes along the axis of the beam. And if you draw the tangent at any point, say for example here B, so this will be like this. Okay. Now, if I take the area of, suppose assume that again, this is some M by EI diagram. Okay, assume that this is a M by EI diagram between these 2 points. This is M by EI. Now, if I take the area between the area of the M by EI diagram between B and A, what it gives you? Actually, it gives you theta BA. Okay. This if you take area of the M by diagram between any 2 points, that is always gives you change in slope between these 2 points. What is the change in slope between 2 points? That is nothing but you can say it is theta B minus theta A. But what is theta A here? Theta A means it is the slope at fixed end. Slope at fixed end will be always 0. So if you put this as 0, so directly this gives you the slope at B. So now, to get slope at any point on this cantilever, what we should do is, you have to take the area between that point where you are finding the slope and another point should be taken as the fixed end, because slope at that point will be 0. For example, if I want to find out the slope at C, now you have to take the area of the M by diagram between C and A, so that gives us theta CA. Okay, and this is nothing but theta C minus theta A, but theta A is 0, that gives you theta C. This, if you take the area of the M by A diagram between C and A, that gives you directly slope at C, because slope at the other end is 0. But whereas if in simply supported beam it doesn't happen, because slope at A is also there, slope at B is there. If you take the area of M by A diagram between those 2 points, it gives you change in slope. Here one of the slope at the point is known. That is the advantage of cantilever beam. Now suppose if you want to calculate the deflection or tangential deviation, let us first assume that is a tangential deviation. What is the tangential deviation at B now? It is a vertical distance at B, that is this you can say, with respect to tangent drawn from A. The tangent drawn at A will be like this. The tangent drawn at B will be like this. The vertical distance between the point tangent at B, tangent at A, that is nothing but this will give TB. So here, as the one of the tangent drawn at A or at the fixed end is always the horizontal, and this is also a deflection. Suppose if you take any point, suppose here, so if you take this as a deflected shape, what is the deflection here? The vertical distance between the point on the deflected shape, suppose if this is B and if this is AP dash, this is directly gives you, or this is the deflection at B. Suppose if you take another point C here, so you have to project this point, say it is C dash, then C dash, we call it as deflection at C. Here, the tangential deviation directly gives you deflection at that point, because again, the one of the tangent drawn at A is along the axis. Whereas here, if you take the tangential deviation of 2 points with respect to simply supported beam, no tangent is coming along the axis or horizontal. So therefore, it gives you tangential deviation directly, not giving you the required deflection. But in case of cantilevers, the tangential deviation at any point directly gives the deflection at that point. Then how to calculate this deflection? Here always, that is what you can say, deflection at any point is equals to, it is a tangential deviation of that point with respect to tangent drawn from A. Always A is the fixed support here. So how to calculate this? This is nothing but area of the M by A diagram between those 2 points multiplied by the distance of the CG of the figure with respect to the point about where you are finding the deflection. So here I am finding the deviation or deflection at B. So area of the M by A diagram between these 2 points multiplied by x1 bar gives you the TBA. That is nothing but, so this is A is bending moment diagram, and if it is A by EI, if it is the area of the M by A diagram multiplied by x1 bar, so that gives you directly the slope at this point. Similarly, now if you want to get the deflection at C, what you need to do? You have to take the moment of M by A diagram between C and A, and you have to take moment about C. Means the moment of M by A diagram between those 2 points, you have to take moment about the point where you are finding the deflection or tangential deviation. Say if this is say x2 bar, then area of the M by A diagram between A and C multiplied by x2 bar gives you directly deflection at C. This is how to get the slope and deflection for